Hi all, I am going to discuss about integration and application of integration in deriving formula, deriving equation of motions. Okay, so integration is just reverse of derivative. So I'll write a formula directly without talking much about integration and its application. Those things will be covered in your mathematics syllabus. So integration of x to the power n dx will be x to the power n plus 1 by n plus 1 plus c. This is an indefinite integration, so c is called integration constant. Integration constant, but basically I'll be dealing with some definite integration. Definite integration means there will be a lower limit and upper limit. So here no limits are there. So x to the power n dx equal to x to the power n plus 1 n by n plus 1. Just keep a thing in your mind that whenever I am doing derivative of x with respect to x, it will be coming as n. For example, I am doing like this. Let's say y equal to x to the power n plus 1. So dy by dx equal to d by dx x to the power n plus 1. So what I will do? N plus 1 whole into x to the power n plus 1 minus 1. So this will be n plus 1 into x to the power n. So whenever I am differentiating x with respect to x or x to the power n plus 1 with respect to x, I am getting x to the power n, means it is getting reduced. But whenever I am doing integration, so basically I got dy by dx equal to x to the power n. So dy equal to x to the power n dx. So if I integrate dy equal to x to the power n dx, integration, this dy integration will be y, and this will be x to the power n plus 1 by n plus 1. So whenever I am integrating, I will be increasing the value. Integration of x to the power n increases to x to the power n plus 1. Derivative of x to the power n plus 1 decreases to x to the power n. So without thinking much, let me solve some problems. Similarly, integration of dx will be giving you x. Simple. Integration of dx will be giving you x, because derivative of x with respect to dx will be giving you dx. Let's say y equal to x. So dy by dx equal to dx by dx. So cut dx from both sides. So dy will be dx. Now I integrate dy. Integration dx. So integration of dy is y, integration of dx is x. So this is the case. So now I'll solve some problems using integration formula what I have told so far. I'm only going to use two things: integration of dx equal to x and integration of x to the power n dx equal to x to the power n plus 1 by n plus 1. But I'll use a lower limit. Let's say simple. First I'll do integration of dx between 1 to 5. So I am trying to add small portion of dx with itself between 1 to 5. So integration of dx is x, and take lower limit as 1 and upper limit as 5. So it will be 5 minus 1. Upper limit minus lower limit. X is the variable. First you put x as 5 minus, then you put x as 1. So the answer will be 4. Similarly, I'll do another two things. Minus 2 to minus 7, let's say. So integration of dx is x minus 2 to minus 7. My upper limit is minus 7 minus lower limit is minus 2. So this will be minus 7 plus 2. This will be minus 5. Similarly, let's say integration of x dx 2 to 3. Okay. Now here x dx above x power will be 1. So I can say n equal to 1 here. So what will be my formula? X to the power n plus 1 divided by n plus 1. Now I am not writing c here. C is integration constant. But since this is a definite integral means after integration I am getting some value. So this will be 2 to 3. So x square by 2. Now 2 to 3. Now no need to get confused. This 2 is constant. Take it outside. Now inside this will be x square between 2 to 3. So half. Okay. Now x is the variable. This square is not the variable. And this square, you cannot take this square out of the variable because it is the power of the variable. So first you put 3 here, then 3 square, minus, then you put 2 here, then square. The simple idea is first you put upper limit, then minus, then lower limit. Everywhere I am doing the same thing. So it will be half. 3 3 are 9 minus 2 2 are 4. 9 minus 4 is 5. So the answer will be 5 by 2. Similarly, if I do another problem, x square dx integration minus 1 to plus 1. So this will be square. Here n is 2, x to the power n plus 1 by n plus 1, because n is 2 here. You need to practice a little bit. After you practicing 2-3 question, you can easily understand how the process is going on. So now this will be x cube divided by 3 between minus 1 to plus 1. Okay, I'm writing it as plus 1. Okay, so 1 by 3 is taken common because it's a constant, minus 1 to plus 1. So only thing is x is the variable, 1 by 3. For x I am putting plus 1 cube. Now minus 1 cube. So this will be 1 by 3 plus 1 cube is 1, minus 1 cube will be minus 1, minus plus. So this will be 2 by 3. Okay. So now using integration, we will derive the first equation of motion, that is v equal to u plus at. So before going to derive it using integration, let me understand what is this. So let us consider 2 points, point A, point B. Let point A is your home, point B is your school. So suppose your father or mother is starting his or her scooty to drop you in the school. Let's say at time equal to 0, the velocity of your father or mother is u. I can say this is the initial position. Initial position means I am taking initial time and initial velocity. So here u is initial velocity. Let's say in going from A to B, your father or mother is taking t minutes or t second or t unit time. Now let's say her or his velocity at time t is v. So I can take as v as final velocity. Let's say it's a final position. So what does it mean? Basically this is a non-uniform motion because I am changing my speed or velocity from u to v. Basically in this situation u is not equal to v. It may be u may be greater than v or u may be less than v. But from the diagram it is clear that it is a case of non-uniform motion and the velocity is changing. And to change the velocity from u to v, let's say you are taking or consuming time t. So in this situation we will be solving. So we'll start instantaneous velocity is given as, or directly you can start instantaneous acceleration. So since it is a non-uniform motion, acceleration is there. So instantaneous acceleration is given as a equal to dv by dt. Instantaneous acceleration is taken as a equal to dv by dt. So a dt equal to dv. So I am just shifting it like this, dv equal to a dt. Now I want to integrate. To get the final value. So we generally do integration to get a value in the larger scale because smaller things are given. We have to integrate. If I integrate smaller things, integration means summation of continuous things, addition of smaller things. Then only I can get some value. So dB, what will be my initial limit when time equal to 0, initial value, time equal to 0, initial velocity is u. So I am taking, let's say my initial value is u1 and final value is v1. In order to avoid confusion, I am taking my initial value u1 because I am using here v. So let's say my initial value is u1. So since this is here variable is v, velocity. Here velocity is changing. So I am taking initial value of velocity, that is u1. So when initial value of velocity is u1, at that time initial value of time is 0. At that time initial value of time is 0. So let us consider this time as t1. When final time, why I am taking 0? Because here acceleration is constant. Here variable is time. Time is changing. So lower limit of time is 0 and upper limit of time is t1. When lower limit of time is 0, at that time initial velocity is u1. When upper limit of time is t1, at that time initial velocity is v1. Why I am taking u1, v1? Because there is a change in velocity. So depending on the variable, I will choose the limit. Here variable is velocity, so u1 to v1. Here velocity, here variable is time, so 0 to t1. Now integration of dv. Remember, integration of dx is x. So integration of dv is v. Lower limit u1, upper limit v1 equal to a is taken constant, integration of dt 0 to t1. Now upper limit minus lower limit v1 minus u1 equal to a, integration of dt is also t, now 0 to t1. So v1 minus u1 equal to a, t1 minus 0 because upper limit is t1, lower limit is 0. So v1 minus u1 equal to a t1. So v1 equal to u1 plus a t1. Okay, I'll do a little bit changing. Let us consider u1 equal to u, v1 equal to v, and t1 equal to t. Say, let us consider. So if I keep, or if I put all this formula in this equation 1, I will get v equal to u plus at. So this is my desired equation. Now I will derive my second formula, that is as equal to ut plus half at square. Before going to derive it using integration, I will understand what is this. So there are 2 points A and B. Suppose you are starting your journey from A at time t equal to 0 and position covered by u will be 0. And suppose you are moving with a starting velocity or initial velocity u1. You are starting your journey with a velocity u1 at time t equal to 0. At that time no time has been consumed and no distance or no displacement has been covered. So position will be 0. Now when you are reaching at B, now time consumed by you, let's say t1, and position changed by you, let's say s1, from 0 to s1. So I'll use it. So now instantaneous velocity is given as ds by dt. I know this. Instantaneous velocity is given as v equal to ds by dt. Now v dt equal to ds. So I am just taking this to the left. ds equal to v dt. But already I have found in my previous equation v equal to u plus at. So I am using it here, u plus at into dt. So what I'll do now, ds equal to u into dt plus at into dt. So now I'll do integration to get the larger value. So ds integration, now u dt integration plus at dt integration. So now how to put the limit, upper limit and lower limit. To put upper limit and lower limit, I have to go to the diagram and choose what are the variables. So in this, in the first term, the variable is position. So position is changing from 0 to s1. So my lower position is 0 and upper position is s1. Similarly here, u is constant because initial velocity value is unique, so it is constant. Now changing time. So your lower limit or lower value of time is 0 because you are starting your journey at 0 second and you are consuming t1 second to cover some position s1. So similarly here a is constant. Now again 0 to t1 because variable is time. So integration of ds is s. So I am putting 0 to s1. Now u is taken common, integration of dt 0 to t1 plus a is taken common, integration of t dt 0 to t1. So now here I will put upper limit s1 minus lower limit 0 equal to u, integration of dt is t 0 to t1 plus a. Now what will be integration of t dt? Let me do integration of x dx. Here n equal to 1, n is here, x to the power n plus 1 by n plus 1. So x to the power n plus 1 by n plus 1. It will be x square by 2. So integration x dx is x square by 2. Integration t dt will be t square by 2. Now 0 to t1. So this will be s1. Now u, this will be for t, upper limit is t1 minus lower limit 0 plus 2 is taken common a by 2, t square 0 to t1. So my final value will be s1 equal to u t1 plus a by 2. The upper limit will be t1 square minus lower limit will be 0 square. So now my s1 will be ut1 plus half a t1 square. Let s1 equal to s, t1 equal to t. Let s1 equal to s, t1 equal to t. And okay, in this diagram I have taken initial velocity u1, but initial velocity being constant, no need to take it u1, you just take it u, t1 equal to t. So this above equation will become as equal to ut plus half a t square. So this is my desired equation of motion or second equation of motion. So I will derive two more formula, that is v square equal to u square plus 2s and s nf equal to u plus a by 2 2n minus 1, which is very important.